So now that we're able to validate the credentials sent by a user, it's also time to make sure that we can then generate this token and send that back to the client that did log in, so that that client can then use that token in the future for requests that are sent to protected routes to prove that it did authenticate successfully before. Now, therefore, we'll have to generate such a JSON web token, such a string that is generated on the server in a way that can only be verified by the server who did generate it. And for that, we're going to use this Golang-JWT package here in our project, and attached you find a link to this package. And on that page, you will also find installation instructions and also usage instructions, though we will of course use it together over the next minutes. So I'll start by downloading and adding this package here to the project. And then I'll add a new file in the utils folder, which I will name jwt.go. And of course, the idea behind that file is that it will contain the logic for generating and then also verifying such a token. So in this file, I'll start by adding it to the utils package, which also contains this hashgo file. And now it also contains this JWT logic. And then in that file, we of course have to import that package which we just used. Though in Visual Studio Code with the Go extension installed, this import will also be added automatically as soon as we use the package. Therefore, let's use it in a new function, which I'll name Generate Token. Here in this function, I want to use this JWT package. And here, if I start typing this, and then in this auto-completion pop-up, I hit tab, this import here will be added automatically. If that's not the case for you, simply add it manually. And on that JWT package, we can now call the new with claims function, which will generate a new token with claims, which simply means in the end with data that's attached to it. Now this new with claims function now needs a method, and with that I don't mean a function attached to a struct, but instead a signing method, so an identifier of the signing approach that should be used for signing that token, which is an important step because that signature can then be checked by that server in the future when clients send such a token to the server to verify that it's a valid token that was generated by this server. And here we can again use the JWT package, and then it's this signing method HS256, which I'll use here. These different methods are in the end simply different algorithms that can be used for signing, and the HS256 algorithm should do the trick for us here. Now, new with claims then thereafter needs a claims value of type JWT claims, so a claims type provided by that JWT package. And we can generate such a claims value by using the JWT package and then the map claims type here. And that in the end is just a type alias for a map that has string keys and then any kind of data as values for these keys. And here I want to include the email address of the user to whom that token belongs, so who logged in into that token, and the user ID, let's say. You should, for example, not include the password here. For security reasons, that should never be exposed anywhere. In addition, I'll add an exp field here, which will describe the lifetime of the token, so when it will expire. And we can use the time package, which is part of Go's standard library, to get the current time, and then call the add method on that, which is pretty convenient that these things exist, to add a certain duration to that current timestamp. And here, I will use the hour type here, or the hour value, and multiply that with 2 to make this token valid for 2 hours. And thereafter it will expire and the client would have to sign in again. And then we actually should get this in the Unix format, which we get by calling the Unix method here in the end. And that will now set this exp key, which will be used internally to make this token expire after this time frame. So thereafter, it won't be verified by this package anymore. And it is a good practice to set such an expiration time so that if that token should be stolen from the client and should then be used by some other user or application, it at least expires relatively soon so that not too much damage can be done. Now, of course, email and user ID also need some valid values, and those should simply be received as parameters on this generate token function. So I expect to get the email of type string and the user ID of type int64. So that we can then set that email received as a string as a value for email, and then the user ID as a value for user ID. So that's then the data that will be included in that token that will be generated. And new with claims will therefore return a pointer to that token it did produce. So here I get my token, I'll store it in a variable, and then here in generate token, I want to return that token. And for that, we can use the return keyword, and then on that token, we can call the signed string method. Because that token type we get back here is actually a more complex value, and I want to get a single string which we can send back to the client and which can then be attached to future requests by the client. And we get that string by calling signed string. However, for that signing, signed string needs a key that will be used for the signing process. And that key will then later also be used to verify incoming tokens. Therefore here I'll add a constant, secret key, and I'll set this to some key, which in reality should be a bit more secret and hard to guess than this key here. But that's now the dummy secret key I'll use for this demo, and it's now this secret key which I pass to signed string. Now signed string then returns a string and an error because the signing process can fail. And therefore, since I'm returning the result of calling signed string here in generate token should return a string and an error. And that's therefore then this utility function which we can use to generate such tokens.